Hello, my name is Dan Rice with Advanced Cooling Technologies. At ACT, we provide innovative thermal solutions for applications for the ground, sea, air, and space. Several years ago, we identified a need for high reliability thermal management of electrical enclosures. In the time since, we have developed several unique products that offer exceptional performance for industrial electronics thermal management. The purpose of this video is to provide a high-level introduction to enclosure cooling. We'll discuss the basics of electrical enclosures, the need for thermal management, and some of the techniques used to address thermal issues in the field. Electronic components are inherently sensitive and must be protected from dust and moisture in order to function as designed. System designers typically house electronics in metal enclosures, which protect the components from physical harm and protect personnel from electrical risk. This applies to many components, including variable frequency drives, transformers, and power supply modules. The need for electronic thermal management is real and is relevant to all industries that take advantage of automation. We see applications in petrochemical, telecommunications, food processing, military, water treatment, and others. Nearly all electronic devices are housed in some sort of protective housing. Enclosures are found in all shapes and sizes, but they all serve the same purpose. Depending on the end use, electrical enclosures can end up in some pretty diverse places. Locations range from clean rooms and laboratories to harsh environments like oil rigs and even the desert. It is understood that all electronic components generate waste heat based on their efficiency. When these components are placed inside an enclosure, the heat builds up and must be dealt with. Some systems are able to passively dissipate the heat, while others require specialized cooling systems to maintain a safe operating temperature inside. There are a number of variables to consider when evaluating what type of thermal management an enclosure will need. It is helpful to know the amount of heat being generated inside of an enclosure, as well as the operating environment, specifically the maximum ambient temperature and whether or not there will be a direct solar load on the outside of the cabinet. Each component should be examined to determine the maximum temperature that it can tolerate, which will drive the allowable air temperature inside of the enclosure. The physical attributes of the enclosure, such as size, construction material, and location relative to other enclosures, is important as well. There are two major thermal management scenarios, commonly referred to as above ambient and sub-ambient cooling. If the enclosure internal temperature is higher than the temperature outside of the enclosure, it is considered above ambient. Fan filter systems and sealed enclosure coolers are two examples of above ambient cooling products. Sub-ambient cooling is when the air temperature inside of the enclosure is cooled below the ambient temperature outside. Thermoelectric coolers and air conditioners are two examples of sub-ambient cooling equipment. In general, above ambient cooling solutions tend to have a smaller footprint and a lower cost than sub-ambient cooling solutions. Once the designer has established a need for some form of enclosure cooling and has narrowed down the search to either an above or sub-ambient solution, there are a number of products to choose from. The table shown on this slide identifies the most commonly used products and some pros and cons. The remainder of this video will focus on the above ambient options, so we won't go into detail here. Looking at sub-ambient technologies, liquid-to-air heat exchangers offer high performance in a compact package. Liquid-to-air heat exchangers rely on a dedicated source of pumped coolant in order to function, which can be a limiting factor in their use. Thermoelectric coolers, or TEC for short, take advantage of the Peltier effect and offer low vibration, solid-state cooling in a compact form factor. A drawback is that the coefficient of performance of thermoelectric coolers is lower than competing technologies, which makes it better suited for low-power applications. Enclosure air conditioners, on the other hand, offer a high coefficient of performance and the ability to address a wide range of heat loads. The downside is that AC systems are known to have long-term reliability issues, and regular maintenance is required to keep the system running at full performance. The last item shown in the table is the Vortex cooler. Vortex coolers are physically small and easy to package, and also highly reliable because they have no moving parts. One thing to keep in mind is that vortex coolers depend on compressed air to operate, which requires a dedicated air source near the enclosure that is being cooled. Because of the large airflow volumes required, this technology is less energy efficient than others. Now let's look a bit deeper into above ambient cooling options. The diagrams shown here illustrate the air movement of the two cooling approaches shown. A fan filter system is shown on the left. Outside air, shown here as the blue arrow, is moved through a filter and into the enclosure where it circulates among the components and gathers waste heat. The red arrow on the diagram represents heated air, which leaves the enclosure at a second opening in the wall of the enclosure. The diagram on the right shows the airflow of a sealed enclosure cooler. Hot air on the inside of the enclosure, which is shown as red arrows, is impinged onto the heat exchanger fins. Heat is removed from the airstream and the air is circulated back to the enclosure, as indicated by the light blue arrows. At the same time, outside air enters the opposite side of the sealed enclosure cooler, as shown by the dark blue arrows. This air passes through the heat exchanger fins, picks up heat from the inside, and carries it away from the enclosure as illustrated by the yellow arrows. There is no cross-contamination of the internal and external air streams. Filter fan systems are simple and fairly easy to install, and they work well in clean environments. They do require some maintenance attention as the filters need to be changed regularly. Even with filters in place, some moisture and particulates are still able to enter the enclosure, which limits the NEMA rating of an enclosure that uses this type of cooling approach. Sealed enclosure coolers are popular for above ambient cooling because they allow the designer to maintain the NEMA rating of the existing cabinet. As mentioned, the design of the heat exchanger prevents cross-contamination of the air streams, which allows heat to leave the cabinet without letting any dirt or water back in. Sealed enclosure coolers are viewed as highly reliable because the fans are the only moving component. Metal fins and heat pipes are the two commonly used heat exchange mechanisms found at the core of most sealed enclosure cooling products. By now you have heard NEMA ratings mentioned several times in reference to enclosures and enclosure coolers. These standards are put in place by the National Electrical Manufacturers Association and correspond to the level of protection offered by a cabinet. For example, a NEMA 12 cabinet is intended for indoor use and protects against dust and dripping liquid, while a NEMA 4 cabinet is able to be placed outdoors and can handle washdown from a hose without allowing water into the enclosure. Another rating that is commonly seen is the Ingress Protection, or IP rating, that is governed by the International Electrotechnical Commission and can be cross-referenced to a NEMA rating. In summary, all electronics enclosures require some form of thermal management. Each application has different requirements and operating environments. Fortunately, there is a wide range of solutions available for dealing with each unique application. In general, as waste heat inside of an electronics enclosure increases, so does the complexity and cost of a thermal management solution. We discussed above ambient coolers and their attributes, which make them ideally suited for lower power applications and for operating in conditioned environments like labs and factories. We also briefly touched on sub-ambient cooling solutions, which work well in applications with high ambient temperatures or those using sensitive components. I hope that you found this introduction to enclosure cooling to be informative. If you have further questions, please visit our website where you can make contact and discuss your application with one of our thermal engineers. Thanks for watching and stay tuned for future enclosure cooling related videos.